Okay, in this second video of applying the four operations to algebraic fractions, we're going to focus on multiplying and dividing. So to start off with, we're just going to look at two basic examples of multiplying and dividing of fractions. Here we've been asked to multiply 3/5 by 5 or by 50 27ths. There's two kind of methods you can go ahead and do this. Method 1, let's move this to the side. Method 1, you can simply multiply the numbers at the top together and you can multiply the numbers at the bottom together, and then you can simplify. So 5 goes into the top 30 times and at the bottom 27 times, and that can be simplified again to 10 over 9. So you can just simply multiply the top numbers, multiply the bottom numbers and simplify to get your answer. Or you can move this over here. You can look at the diagonals and see if anything can divide both of these quantities. So the biggest thing that divides 3 and 27 is 3. So both of these can be divided by 3. 3 divided by 3 is 1, 27 divided by 3 is 9. And then looking at my other diagonal, 5 and 50. 5 divided by 5 is 1, 50 divided by 5 is 10. And then I just simply read along the top. 1 times 10 is 10. 1 times 9 is 9. Okay, so there are two approaches to multiplying fractions. I would recommend trying to cross simplify if you can, because it's a lot quicker and you won't need to do all this simplifying. Okay, here we've been asked to divide 8/11ths by 2/33rds. Our method when we're dividing fractions, the first fraction stays unchanged. We flip the second fraction upside down and the divide in the middle becomes times. And now we're just at a regular point of multiplying fractions again. So let's look diagonally. What can divide 8 and 2? Both of those can be divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And then looking at my other diagonal, 11 and 33, both of those can be divided by 11. And 33 divided by 11 is 3. So 4 times 3 is 12. 1 times 1 is 1. And I'll just write that as 12. Okay, so those are the two basic examples of multiplying and dividing fractions. We're now going to look at some examples, including algebra. Okay, in this video I've been asked to multiply 6r over 5 times 3 over 5r. Just one thing to note, when we're multiplying and dividing, we don't care if the numbers at the bottom are the same. We don't care. Okay, so first thing, let's look if things can simplify diagonally. So we've got the numbers. Look at your numbers first, 6 and 5. The biggest thing you can divide both of those things is 1, so that's not helpful. However, we've both got r and r. And since 6r is multiplying and 5r is multiplying, I can cancel out these r's here. And looking at my other diagonal, I can't simplify there. So I'm simply going to be left with on the top, 6 times 3 is 18, and 5 5s are 25. Okay, in this example I've been asked to simplify 7ab over 9 by 27 over 2a squared b. So first let's look at our diagonals. Let's look at the numbers first. 2 and 7. No, we can't really do anything there. Let's look at our letters now. AB, and I've got an a squared b here. Remember, a squared means a times a. So essentially on this bottom line I've got 2 times a times b. And on the top I've got 7 times a times b. So hopefully we can see straight off that the b's can cancel. And this 1a can cancel with one of the a's in a squared, because a squared meant a times a, and I can cancel that with this a at the top. On my other diagonal I've got 9 and 27. They can both be divided by 9. 9 divided by 9 is 1. 27 divided by 9 is 3. And then I just read along the top. 7 times 3 is 21. On the bottom, 1 times 2a is 2a. Be very careful when you're doing this, you're remembering to include all your terms. Okay, and I'm just going to finally focus on this 1 dividing fractions one, and I've made it a little more complex, but it's just essentially multiplying fractions. Okay, so remember, when we're dividing fractions, the first fraction remains unchanged. The second fraction we flip upside down and divide in the middle becomes times. So now we're just at our multiplying fractions stage. So let's look. 2 and 5. Can something divide both of those? No. Let's look at our letters now. Let's look at a cubed b squared and a squared b. A cubed means a times a times a. A squared means a times a. So what I can do from here is I can cancel this a squared with a squared from this a cubed, which is just going to leave me with a to the power 1. Because a cubed is made up of a times a times a. So I could cancel that away. I can also cancel this b with one of the b's from b squared. B squared means b times b, and I can cancel that with one of these b's here. Looking at my other diagonal, my numbers first, 4 and 5, can't do anything with that. Looking at my letters, c and c squared. Well, I can cancel c with 1c there. So, what I will now have on the top, I just need to make sure I read this really carefully. I know how I wrote a to the power 1 here, just to try and illustrate what was happening, but I'm not going to include that 1 there, because anything to the power 1 is just the thing itself. Okay, so at the top, let's look at the numbers first. I've got 2 times 4, so 2 times 4 is 8. I'm also left with a and c. So at the top, I've got 8ac. At the bottom, I've got 5 times 5, 25.